So any number we take, okay, any number like 2, 3, 4, 0, 0, 0. So what is trailing zeros here? These zeros which are at the end. Okay. So number of those trailing zeros here are 3. Okay. You guys get. Now if I'm taking 1, 2, 0, 4, 0. So what is the trailing zeros here? Only 1. We don't consider this. The last one. Okay. So the first approach we are dealing with. Okay. Now this, for example, first I'm going to tell that these trailing zeros we need to find in a factorial. Okay. So first we need to find a factorial. Now, for example, the 5 factorial, if I'm taking, I need to calculate its factorial. Then I want to find its the trailing zeros, which is 1. Okay, so the user will actually put this. I need to calculate the factorial. Now this thing only is the very big task. You guys know already. Okay, so let me check with this by the naive approach. Okay, so naive solution would be calculate the factorial first and check count of trailing zeros. Okay, so this factorial thing I have covered in the last video, right? Now checking the count of trailing zeros. How will we doing? 120, for example. I will run a while loop where I will check whether this thing is greater than if this thing. No, see, the most important thing is the trailing zeros, right? Now I want to take this thing out from the whole number. I want to convert 120 into 12. I need this 0 also. So how I will do? 120 divided by 10, I will get 12, and 120, this mod 10, I will get 0. Okay, I need this also then here. So first I will check whether there is any remaining, remainder has 0. So that I will do by doing this. Okay, it will check. Now 120 mod 10 equals 0. Yes, because there is a 0, right? Now what I will do is, I will then remove that. Okay, I will remove it. I will convert it to 12. But at the same time, I will actually increment my count or the result, which was 0 first. Now, while this thing is coming here, taking this mod out, okay, it will check, it will give true, then it will come inside and it will convert 120 to 12 because it is dividing by 10. At the same time, I'm doing result as 1. Okay. Afterwards, then it will check whether 12 mod 10 is equals to 0. The answer is 2, so it's not 0, right? So it will come out of while loop. Then it will return. This thing is fine, but the thing is calculating factorial is the very tough task. Because sometimes some people will just put on 1000 factorial. It will be very hard to deal with it. But there is also overflow problem, which that's why we will come to the next, the efficient way of solving or dealing with this problem. Okay. So if I'm taking, for example, this is an efficient code. Okay, I'm just discussing the efficient code. In the next video, I will efficient approach. In the next video, I will teach you guys the code of both the methods. Okay, efficient approach, how it will we will deal with 5. Okay, now just observe here. What makes a number should end with 0? What makes it? For example, if I have 12, what makes it should end with 0? Of course, the 10. Okay, any number, if I take 35, if I multiply it by 10, it's 350. I need that number, right, at the end. So how I get it? By giving this 10, okay, 10 thing. But I can't calculate. See, here in 5 factorial also, 1 into 3 into 4 into 5, I don't find any 10 factorial, a 10 number. Okay, multiply by 10, I can't find here, right? So what it makes, what that thing makes here, 0. You guys have already guessed it. It's 2 and 5, right? 2 into 5 equals to 10. Okay, so 10 10 powers, we are actually dealing with 2 power and 5. Okay, only these two numbers can bring on to 10. And no, it's like our goal mission to find those powers of 2 and 5. Okay, but the thing is, it's been observed that powers of 2 is very less, okay, compared to the powers of 5. So our main goal would be only to find the power of 5. Get it? So this way we are going to deal with, actually jot down to finding only the powers of 5. Okay. Now, let me show you this thing. For example, if I'm taking 25 factorial, there is 1, there is 2, there is 5 also. Okay. There is 25. You observe like 25 has to deal with 5 and 5 again. There are 2 5s, right? We have to nullify that thing. There is no, like, we have to find the powers, right? We have to find the powers. So what we will do is, there is a method called Legendre's solution, which is specially for dealing with the trailing zeros in any factorial. Okay, what is it? Like, for example, now we have this 5, now we have this 25, we will have 125 also. Okay, this 5, and 125 also has 3 5s. There are powers of, right? There is a powers of 5. Okay, there are some powers of 5. So this thing we have to calculate. So how we will do is, we start with 5 itself. Okay, then what we will do is, we will multiply, increment it by multiplying by 5. Now what it is, like, see, I will show you, this is the formula, actual formula, right? Now what is this? You can see, you guys can see, it is nothing but taking that n number. N is 5, okay? For example, it is 5. I'm taking that 5 number. Okay, I will divide it by 5, so I will get 1. This is the only thing. This is very simple. If I'm taking 25, so we know that 25 divided by 5 equals to 5. Okay. Also, there would be a factor which is 25. So even this term will also include, plus 25 divided by 25. So it is 1. So the answer would be 6. If you even check now in the internet, the factorial of 25 is 6. This is how we deal with it. If you ever say in the interview how to find the trailing zeros, this is the actual solution. Okay, this is the actual solution. The solution is called as Legendre's solution. Okay, it will deal with, we have to take the number from the factor. There is no need to calculate the factorial here. Okay, there is no need to find the factorial here. Just we have to take that number, we have to divide by the powers of 5, and we have to cumulative addition. Okay, we have to add it. How many times? Any time it will be, we have to add those numbers. Okay. So this way we have stopped the theory part here. You guys can continue seeing the code also. Code is very important. So next video I will discuss the code of these both methods. So you guys can have a look on it. And also I need to mention that the code, the efficient code has the time complexity log n, because we are actually incrementing it by multiplying by 5. So it is log base 5, but we don't write any 5 or any base here. We just write the log n. So anyone asks what is the efficient solution, what is the time complexity, so you can explain the solution, as well as we can actually mention the time complexity. Okay, in the next video I will explain the code. Thank you.